All right, so I'm just going to go over the meeting from today because a lot of you had trouble with the Zoom, so we're just going to talk about it now. Okay, so basically today in class we worked on going over some of the important information for the lab that people were struggling with. Just put this up for a second. So this lab that we're working on, a roller coaster sim, is going to act as your test for the unit. So you're basically not allowed to fail. Everybody's going to shoot for getting this A now to demonstrate to me that you understand the content of energy, energy transfer, and how it go definition of mechanical energy, potential energy, and kinetic energy, what these things depend on. So I'm going to keep making comments on your roller coaster sim until you get it right. So today in class, many people were able to finish that up. For those of you who do not finish it and get it kind of good, I'm going to ask you to meet with me on Friday to do the same thing. Make sure that we're getting this right. So your goal is to finish this by the end of the day today, which is 3 or 4 o'clock p.m., so that I can grade it tonight, so that we can kind of see who needs to still come in before Friday. So I definitely want to do that. All right. So these were the questions from the sim questions that people were struggling with. I'm going to work from the backwards forwards. And if you have more questions, you're going to have to reach out to me. So go over to the bump loops thing. And then just a quick reminder, when you explain things, you can't just say because it doesn't have enough kinetic energy. You need to explain why. How do you know it doesn't have enough kinetic energy? The speed is the same because it has the same kinetic energy. Well, how do you know it has the same kinetic energy? You want to use reasoning, which is going to include talking about what mechanical energy is, how it's conserved, and how it transfers. And again, PE goes as the height, kinetic energy goes as the square of the speed. So this information, what evidence, when it asks you to show evidence, screenshots of the bar graphs. That's really is what we're looking for here. All right, so we're going to go to the bumps, and I'm going to do a little bit of the annotation of the screen here. So I got my little drawing tool. So this is the beginning part. This is point C, which has been relevant to what we've done before. This is point D down here. This is E. Make this an E, and this is going to be G, and this is H here. So we kind of have all the points labeled. There's point F. Okay. The first thing that is important to this lab is to make sure that you put the dots where they need to be. So F is the lowest point. I put it all the way to the ground. E and G need to be the same height. So if you click on these gray dots, you'll see the dotted lines, and you can see that at the very center of the big gray dot, there's that dot, the small dot. And I put it right on the grid line. So it's right there on this line. And same thing for E. If I click on it, the center dot is right there. So I know E and G have the same height. Okay. So I got the car at the very top of the ramp. I hit the reset button. So this is telling me how much mechanical energy is in my system. And then this tells me it's all potential right now. It's not moving. So what this means is this defines the total energy of my system. So again, I'm going to draw a line here, right here through the center of the car to the edge here. So when the car goes up and down the ramps, because this is the total energy of the system, it can't go any higher than that line because that would violate conservation of energy. So when we talk about point H, it's not that it doesn't have enough kinetic energy. Well, how do you know it doesn't have enough kinetic energy? You have to talk about what happens in the beginning and where the car starts and how the total energy of the system is defined. So that kind of addresses one of the earlier questions. I'm going to work backwards a little bit here, and I'm going to talk about the last question, which was talking about changing C and what happens to the speed at D. We want to look at this from a perspective of energy. So we want to look at how much kinetic energy the object has, and I'm just going to pause it when it gets to point D here a second. So it gets close. I'm going to step it so that it gets to point D, all the way there. Okay, so you can't get it quite all the way to the bottom. It's got a little bit of a tilt to it, but this is my original, and this is telling me how much kinetic energy I have on my system. So if I kind of, again, draw the little squiggle line right here, that's how much kinetic energy I have for my original position. Now what I want to do is make a change to C and see what happens to that kinetic energy. So this is the evidence you want to collect, a screenshot of it. So I'm going to go back to the mouse here, and I'm going to take C, and I'm going to, this time I'm going to raise it up a little higher, but I don't want it to go too high to break it. I still want to be able to, for the car to get to point D. So I just made it a little higher. Is that going to affect how much kinetic energy I have? So if I reset it and let it go, and again, I'm going to pause it close to D so I can take a little screenshot of this as my evidence. I'll pause it. Okay, and step. There we go. Right there. See? Same amount of kinetic energy. So I change C, I still have the same kinetic energy, which means I have the same speed. So that's kind of the proof. Screenshot this. That's part of the proof. Okay, now I want to make C really low and see if that changes the speed at D. Again, this is my marker right here. I'm going to reset it, hit the start button, and let it get to point D and see if that changes anything. Again, step it through. Look at that. The evidence is there. Screenshot it. Now explain why. Why does changing this height have nothing to do with the kinetic energy there? And again, look at what the bar graphs are doing. What affects how much kinetic energy it has at point D? That's what you want to look at. All right. So the next thing, I'm going to erase this a little bit here, is the Macintosh question. So the Macintosh question is asking who's correct. Mac says F is the fastest speed because it's the furthest along the track. Tosh says no, it has to do about the change in the height from where it started. And again, that's the big idea that is pretty much part of every question that we're answering. So the best way that you can modify the track, I think, in order to prove that, is to just grab one of these dots, oops, and bring it down to the same height as F. So now I've made this modification. And again, if I take a screenshot of how much kinetic energy is here and how much kinetic energy is at point F, screenshot both of those, I can compare them. And if Mac is correct, then F is going to be more speed than this point right here because he says it's because it's further along. But if Tosh is correct, then these would have the same kinetic energy and the same speed at these 2 points. So that's a basic modification that you can do for the Mac and the Tosh question. All right, other questions, the ranking of potential and kinetic energy, that basically, if you need help with ranking potential energy, it goes as the height. So we know that. So F has the least amount of potential energy, and we can see that from the bar graphs, but we can just look at the picture and see that. And H is going to have the most. So you just want to rank that in order. Make sure that you follow the directions and use the less than or the equal signs. So again, E and G have the same height, so think about that. And then the other thing that you'll notice when you're ranking the potential energies and the kinetic energies, you know, wherever it has the least amount of potential energy, that's where it's going to have the most kinetic energy. So again, so we can kind of see what's happening right here at point F, where it has the least potential energy, it has the most kinetic energy. So remember, the ranking is from smallest to biggest. So make sure that you're kind of following those instructions. All right, and then the last question that you might have need help with, I think we already talked about, why doesn't it reach point H? That's the beginning of the video. So again, what I'm looking for is for you guys to write detailed responses. A single sentence is really not going to do it. I'm going to kind of keep making you doing it over and over again until you kind of really hitting all of these points that I am trying to get you. And this slide is is posted on Google Classroom, so you can see it. If you have any questions, email me, but this needs to be done by tonight, 3 or 4 o'clock tonight, so that I can grade it and give you the proper feedback, and so that we can put this all to bed by Friday, before Friday. I don't want anybody to have to meet with me on Friday. All right, that's it. You guys are all set. We'll talk to you soon.